So yesterday we finished the first part of this. Now this whole page is most of what FRQ3 will look like. It'll also include trig stuff. We haven't even talked about the trig stuff yet, but we can do a whole lot of it before we ever even get there. So remember that these are all going to be wordy. So you just have to get over it, all right? And you got to read through it bit by bit and label things. I'm not sure if I said this yesterday or not, or clarified all this, but your AP exam is a hybrid exam, meaning your all the multiple choice questions are 100% on the screen, and you have scratch paper to write stuff down on. When you get to the FRQs, the questions themselves will be on the computer, but you will have a booklet in front of you. For 3 of the FRQs, you just have some lines with like 1A, 1B, but no pictures or graphs. For FRQ3, you will not have the picture like of the clock or whatever the problem situation is. The only picture you will have will be this, and it will be blank, and it'll look exactly like that. But that's it. So when you're here and, whatever the situation is, they're telling you, talking to you about a clock, and you can see what it is. On your scratch paper, you should at the very least draw something that looks like this so that you have something to label and make yourself understand what's going on. It doesn't have to be beautiful, it doesn't have to be super accurate, but something where you can wrap your mind around whatever so that you can get things labeled, right? So we came up with those 3 ordered pairs by reading through this and labeling all that. So then we were able to label on here. And remember that that dotted line is the midline. That's literally in the middle of the 2 solid lines. Not only are the y values equally spaced, but so are the x values. So even if I can at least get my max and min y values, I could figure out what that 120 is, even if they hadn't told me that stuff, although I used the 120 to find those numbers. And even if I could only come up with 0 and 30 here, then I could easily come up with this one here and go from there, because everything is half, half, half. All right, so with all that said, let's look at B. It says refer to the graph of H in part A, and the T coordinate of G is T1. So here's G, this is T1. And the T coordinate of J is T2. So here's J, and what it's like that. That is T2, okay? On the interval from T1 to T2. So I'm not looking at the entire graph. I'm only looking at this interval. So even if I don't label it T1 and T2, which I may not do that again moving forward, I would at least shade or scribble in or whatever that section of the graph. That is the part that I'm looking at right now. And it says on this interval, which of the following is true about H? Okay, if we're only talking about the graph itself, do I need my fun chart? No, I do not. So I would suggest we don't write it so we don't confuse ourselves, okay? The function itself, just the little purple squiggly part I have there. They're asking me, is H positive or negative? What do I look at to determine that? The y's. I'm looking at my output values. So when I look at these 2 output values here, those are both positive, right? So my answer would be positive, so I can eliminate C and D. And then that section of the graph only, is that section of the graph increasing or decreasing? Decreasing. And that's my answer, okay? You could answer that from August, right? I mean, we've been doing that all year long. The other thing is, one of the questions that comes up, because we're going to do a lot of these different problem situations, but one of the questions that comes up is, what if, like yesterday we had one where the outputs were, I think it was 3, 0, and -3. Well, still, if it was that same part, because these are open intervals, and it was this section here, that would be negative. They're not going to ask you to go from like here to here, or make this like a +2 and this a -3, and then ask you that and it be both. That won't be part of the question, so you don't have to worry about that. That's usually a question I get. It's not going to be, nobody's trying to confuse you on something like that. Okay, so then we move on to the next part, and it says describe how the rate of change of H is changing over this interval. So now if we're talking about the rate of change, what should we write down?
Fun chart.
The fun chart. I highly encourage you on a lot of the situations, even if the fun chart's in your head and you don't feel like you need to write it down, sometimes I think it's still good to write down, because then you can label kind of what you have on that particular fun chart. So I'm still looking at that same little purple squiggly part. And that part of the graph, is that part of the graph concave up or down? Up. So I'm going to label this right here so I don't lose track of anything. And is that part of the graph increasing or decreasing? Decreasing. So therefore, on T1 to T2, the rate of change is increasing and negative. Do we agree with that? Yeah. Okay. So now let's go back to this question. It says, describe how the rate of change, okay, and we've figured this part out right here, right, is changing over the interval. What describes how it's changing? The increasing part or the negative part? The increasing part, because the whole time on T1 to T2, the rate of change is negative the entire time, right? So that's not how it's changing. It is changing because it is increasing, all right? Now, they actually added a part, like another sentence to this part of the question, and I don't remember exactly how it's worded, and I forgot to look it up, and I forgot to change this, but it basically implies that you have to also explain yourself. It says describe it, but you have to explain it basically using your fun chart. They don't use those words because that didn't come from College Board. But anyway, we have to answer it and explain ourselves. All right, so let's answer, how is the rate of change changing? So I can say the rate of change of H is increasing. Now, is the rate of change always increasing in this function? No. It's increasing on T1 to T2. That's all we really care about anyway, right? So I'm just talking about that part. I've answered it. The rate of change of H is increasing on T1 to T2. And then I have to explain why. Because, okay, H is concave up. Is H always concave up? No. Concave up on T1 to T2. And I know saying T1 to T2 seems repetitive, but get over it. Your opinion doesn't matter. My opinion doesn't matter. We got to say what they want us to say to get our points, right? Any questions at this point? Now, here's what I see sometimes is I know y'all figure out that it's increasing because it's concave up, but then you write it's increasing because it's concave down. And sometimes that happens because you either didn't write down your fun chart, or you did, but you didn't actually label it, or you did, but you didn't look back up at it. Remember, this is FRQ3. The test is getting close to done. You're tired. It's been a long time. I know you're smart. Smart people do dumb things sometimes? Absolutely. So we want to try and minimize those things. Also, you got to make sure you say certain things. The rate of change of who? H is what? Increasing. Where? We don't always have to say the where if it's happening the entire graph, like if it was logarithmic or exponential. Then I have to say because who is what, where, right? Who, what, where, who, what, where. We're good so far? Also, anytime you have an explanation that you have to write out, reread it. If you have the word it in it, mark out the word it and write what it is, okay? Even if your English teacher would be okay with it, nobody cares. Don't say it. Say what, you can't say like the rate of change of H is increasing on T1 to T2 because it is concave up. What is it? Mark out it, put H. You with me on that? What other questions we got? Anything? Okay, so remember there are 6 points to each FRQ. This one is a trig-based FRQ. There ain't nothing trig about what we just did, because like I said, it's not the whole thing. But this is 3 of the 6 points. Getting the points on here correctly is 1. You will have a question that is, it'll be some part of the graph, not necessarily that specific part, but asking you pretty much exactly what this says and something that's pretty much exactly what this says. That is 3 points that you should be able to get pretty easily. Even if you completely mess up the ordered pairs and that confuses you, does that have anything to do with these 2 answers? Not at all, okay? So don't get frozen up on something. You can still get 2 out of the 6 points, okay? Everybody good so far? Any questions at all? Okay, great. So we are done with that for now. If you haven't already taped it in, go ahead and do that. I'm going to give you a warm-up, and I'm going to give you about 10 minutes to work on this. And then we are going to talk about it together. Okay. You can use your notes, maybe use your last warm up if that helps you some. All right, you got 10. You had to work your brain. Okay, so yeah, sorry. Yeah. So on A, let's work A, and then you can be mad at me. When I worked this question, I actually it was another one of those where I got to the end and then I was like, let me check the key. Like I know I did it right because it's not that hard, but then I was like, this just seems like a mean question. All right, so we got 4 log base 3 of x equals 36. Okay, so we divide both sides by 4. We agree with that, right? So we get log base 3 of x equals 9. Then I need to get the variable out of the log. So I'm going to exponentiate. The base of my log would be 3. So those get to basically go away. So I get x equals 3 to the 9th. And yes, I failed to tell you, well, here's the thing. Technically on this question, everything has to be multiplied out. This seems like a mean question, right? Because nobody's really testing whether or not you can multiply. Should you be able to multiply? Yes. Are we capable of this? Yes. Do we not like it very much? No, none of us really like it that much, unless you can do it in your head. And if that's you, just keep it to yourself because we don't want to hear it. Because it just makes me mad. But let's talk about also how to work smarter, not harder. If you did have to do something like this, like you can literally do 3 times 3 is 9 times 3 is 27 and keep going. But if you think about, not just in this situation, but in other things too, isn't this also 3 to the third times 3 to the third times 3 to the third? Like, because you would add the exponents. Is that the same thing as 3 to the 9th? And what is 3 to the third? 27. So it's also just 27 times 27 times 27. So you can do 27 times 27. Yeah, you get a big number, but then multiply that by 27 so you don't just keep doing over and over again and keeping up with 9 threes, because sometimes that's where you mess up too. You lose track of what you're doing. But no, I wouldn't expect you to have to do some crazy stupid number like that. And yeah, whatever. You can be mad at me, I guess. All right, but are we good on that? Okay. Then B, this one also should be fairly simple. We've got 2 times the natural log of x plus 3 equals 5. And I could make 2 an exponent, but if I don't have to, I'd rather not. So I'm going to divide and get the natural log of x plus 3 equals 5 halves. Then again, I need to get the variable out of the log. So I'm going to exponentiate. Base of that log is e. So get e down here. That gives me these take care of each other. So I get x plus 3 equals e to the 5 halves. Nobody expects you to know what that is. X is equal to e to the 5 halves minus 3. Okay. Looks weird, but whatever, right? We okay with that? All righty. These down here, I think the best way to attack this is to do them kind of all in one step so that you don't lose anything along the way. We want to write j of x as a single logarithm. So this 4 can become an exponent. This 1/2 becomes an exponent. We've got 2 logs, same base that I'm subtracting. So j of x is going to equal, that first term is positive, so x to the 4th goes in the numerator. Second term is negative, so it goes in the denominator. And you can leave it as y to the 1/2 or make it the square root of y. It doesn't matter either way. Okay. I forgot that. God, I did that again. Don't do that. Thank you for catching me. I'm so focused on the division. But you see how easy it is to make that ridiculous mistake? Unfortunately, I kind of do it a lot. So don't be like me. Okay. We good? All right. Then, I guess we'll just leave it here. Same thing. Do this, especially if there's more than 2 terms. Do it all in one step. This one doesn't have a coefficient, neither does this one. So this is k of x equals log base 10. Let's write that before we worry about anything else. And then that first term is positive, so the x squared goes in the numerator. The second term is negative, so the 4 goes in the denominator. Third term is positive, so the y goes in the numerator, and you're done. Okay. If you put them together or take them apart in more than one step, a lot of times that is where the mistakes happen or the confusion happens. Okay? Questions? Okay, great. So now we've got this one. We've got 3e to the 2x plus 4e equals 5e. I didn't even read it, but y'all know what's supposed to be happening here. These two terms on the left I cannot combine because the exponents are different. But I can combine the 4e and the 5e, right? So I can subtract over there. I can get 3e to the 2x equals what? E. Yeah, 1e, just e. Then I'm going to divide. And there's two different ways to divide that. And I'm actually going to work it both ways. I can either end up with e to the 2x equals e over 3, which is totally fine, or e to the 2x equals 1/3 e. Do you agree that those are the same thing? Okay. Your answers may look different in the end depending on which one you did. One is not better than the other. But it is important that you understand that these two things here are the same. Okay, we okay with that? So if I work it one way and my answer in the end is different than yours, don't start scratching things out or erasing because you're not necessarily wrong. Okay, so here I've got, I need to get the variable out of the exponent, so I'm going to take the natural log of both sides. On the left-hand side, those take care of each other. I'm left with 2x. Equals natural log of e over 3. Okay, that I cannot just mark out that natural log in e. I have the natural log of two terms that are being divided. So then I can change that to 2 logs that are being, oops, not e, natural log of e minus the natural log of 3. You agree with that? Right? Okay, because that's a division, that's our division rule. Now, natural log of e is 1. So then when I divide, I can get x equals 1 minus the natural log of 3 all over 2. That is one acceptable answer. Everybody okay with where all that came from and why? All right. Acceptable answer number 2. I still would take the natural log of both sides right here. So now that again takes care of itself, right? So I end up with 2x equals the natural log of 1/3 e. Now I have the natural log of two terms that are being multiplied. So this can become 2x equals natural log of e plus, oh well, I guess 1/3 came first. It doesn't really matter, but you would probably do the 1/3 first. I wasn't looking at what I was doing. Plus the natural log of e. It doesn't matter either way. Everybody with me so far? Natural log of e is still 1. Dang it. Freaking phone. Okay, so now that gives me x equals natural log of 1/3 plus 1 all over 2. Now, those two answers look different, right? But they actually do have the same value, and I want to show you so that you understand why they are actually the same. If I take just this natural log of 1/3, I can rewrite that as the natural log of 3 to the negative 1 power. Would you agree with that? And then that negative 1 can come out front, so that's the negative natural log of 3. These two things have the same value. So if I change that to negative natural log of 3, basically I get that version of it. Okay? But both versions are considered simplified all the way. It's not like I can make the natural log of either one of those into an actual number. Okay? Questions about that at all? One's not better than the other. You just got to show your work and how you get there. Okay? So there's no magic really happening. Any questions? All right. Good deal. I used up all that space over there. Now, a couple different ways to approach this one. Let me just write it down. 5 to the 2x minus 1 equals 1 over 25. Now, either way you did it is perfectly fine. So I don't want you to feel like you can't raise your hand, but raise your hand if you worked this by introducing a log. Anybody? Okay. All right, so if I do that, okay, I'm going to start off that way, and my log would have to have what base? 5. So log base 5. Log base 5. Okay. So over here, that takes care of itself. And I get 2x minus 1 equals log base 5 of 1 over 25. Everybody with me? Even if that's not how you worked it. Okay, so now at this point, I want you to remember that if you can actually calculate the log you need to, like over here, calculating the natural log of 3, you can't do it. Log base 5 of 7, you can't do it. But if these two numbers are somehow related to each other, then you most likely can. And if you can work through this that way, that's fine. I think for some of us, once we got to that point, instead of, because remember the other one we did on this, it was way hard. This one isn't necessarily that hard, but the other one was weird. And you had to put like a square root and stuff in there. So if you can handle this and keep going, that's fine. Or some of you might get to this point and then be like, you know what? I think this is telling me there's also another way to do it, which again is not necessarily better, but it might be better for you. Whereas if I was here instead, could I get these to have common bases? Yes, so I'm going to pause right here. And if you didn't and you kept going, that's totally fine. And then you told him you don't need me to work it, I don't think. But I can get 5 to the 2x minus 1 equals 5 to what power? Negative 2. So then I get 2x minus 1 equals negative 2. 2x equals negative 1. X equals negative 1/2. Okay. And if you did it with the log, did you also get that answer? Okay. If not, do you want me to continue working that one? I can't? Okay, I can do that. All right, so then I'm going to come off of, let's see, use a different color here. We're going to come this way. So let me keep going here. So then that means I want to be able to make this into a base of 5. I want the base of this, make this into an exponential where the base matches this base. So I'm going to have 2x minus 1 equals log base 5, which means I need this to be a 5. That would be 5 to what power? Negative 2, right? Let me scroll some. Oops, not that much. Okay. Because the negative gets it out of the denominator and it'd be a negative 2. So 5 to the negative 2 power is 1 over 25. We okay with that? So this right here matches this right here. And then since these match, that can go away. I get 2x minus 1 equals negative 2. And then I'm right back where I was over here. Okay, it's just a different way to get there. And that's why I say, if that can, you know, that one again wasn't too bad. The last one, I think we had to make it like a negative 1/2 or something. And sometimes your minds get backwards on those things, or you don't, it's not as obvious. But if you could take it either way, 5 to 25, or, you know, 4 to 2 or 2 to 4, whatever it was, try maybe getting a common base. Okay, that just might be a better option for you. What questions you got? Anything? Okay, so I thought these 2 warm-ups were pretty good. This is the stuff that's on your test next week. So make sure you go back over these. I'm going to give you your review now.